Hello everyone. This is week 10's work. This will be the last week and last assignment that you have to do for the rest of the school year. This week we're still going to be talking about logarithms and going a little bit more in depth, and specifically we're going to talk about the different kinds of properties that logarithms have. And there are kind of weird properties that they have, but you still need to have the website here, the GeoGebra one that we talked about the last couple weeks here. So you still need to have this up so that way we can evaluate logarithms, and it will be helpful, especially compared to having your phone calculator. But later on I'll also show you how to use the phone calculator to do these logarithms. As right now you don't know how to do it though. So let's get into it. This is 9.7, just properties of logarithms. So how do you expand and or condense? You'll see these two words a lot. We're going to expand logarithms, and then we're also going to condense them. Practice doing that. But first, we're going to try some of these in a calculator and kind of see how they're related. So let's look at part A. Log base 10 of 100. So I don't know if you remember, but log base 10 is the same thing as writing log of 100. Remember, you don't have to put the base 10 there. But either case, you can do it. You don't have to do it. It doesn't matter. So log base 10 of 100 is the same thing as log of 100. We're going to put this in the calculator to see what it is. And since I don't need the base there, I can just type log. So make sure you go to f of x. Actually, it does include the base there anyway. But log base 10 of 100 is 2. So this equals 2. Going down to part B, log base 10 of 10 plus log base 10 of 10. So let's plug one of these in. Let's do them separately. Log base 10 of 10 first. So log base 10 is already up there. Let's change this to 10. So that means it's going to be 1. So we have 1. So this part is just the number 1. Plus, if we do it again, we already know what it is. 1 equals 2. Okay, part C. Log base 7 of 343. That one we cannot write as just log of 343. It does not have base 10. So we'll type that in here, change this to a 7, and then this to a 343. 343. That's the number 3. Okay, part D, log base 7 of 49 plus log base 7 of 7. So let's put both of those in there. Maybe I can put them in there one at a time. Log base 7 of 49. 49, that's 2. So the first part is 2 plus log base 7 of 7. Just change this to a 7. That is 1. Whoops. 2 plus 1 is 3. So there's this kind of property here where if you look at just A and B and compare those two and the answers we got, and look at C and D, comparing those two, what can we say about these two? We know that log base 10 of 100 is 2, but then we also know that log base 10 of 10 plus log base 10 of 10 is also 2. Same thing happens over here. If you have log base 7 of 343 equals 3, and then these two separately gives you 3 as well. What's happening? Why do they equal the same exact thing? Is a question. Well, what's really going on in the weird property of logarithms is that when you have a plus sign between two logarithms of the same base, you can actually put them together. Think about putting them together into one logarithm with that same base. And what you do with these two numbers here is you actually multiply them together. So 10 times 10 gives you 100. Same thing actually works with this one over here. It may not be as obvious to see because you may not know what 49 times 7 is, but when you multiply them together, you get 343. Which is kind of weird because what's between them is a plus sign. So again, if they have the same base, the 7s, and there's a plus between these two logarithms, you can condense them. We use the word condense. We can condense them into one logarithm with the same base, and you just multiply those two numbers beside it together. 49 times 7 is 343. So we're going to check to see like how this works. We're going to try it again. So log base 3 of 27 plus log base 3 of 243. So what I'm going to do is I'm going to use the property that we just talked about to condense them. Condense each expression into one logarithm, and then we'll check to see if they're equivalent. So log base 3 of 27 plus log base 3 of 243. That means we need to multiply these two numbers together. What's 27 times 243? Let's put it on here. 27 times 243. Right? Is 6561. So we're just going to check and see if this is right. Does it actually work? So let's do them individually. Log base 3 of 27. So I'll just click on the button here. Log, what was it, base 3 of 27? That gives you 3. So this part gives you the number 3 plus log base 3 of 243. So change this to 243, that's 5. Which equals 8. So it should equal 8. So we're going to check and see, does this work? If I multiply those two numbers together and get 6,561, if I put this in the calculator, will I also get 8? Log base 3, 6561. It's nice to keep that base there. 6561, it is 8. So it does work. We'll do another one quickly. Log base 9 of 81 plus log base 9 of 9. What's 81 times 9? 81 times 9, 729. So this is what? Log base 9, keep the same base, 729. And then we'll just check them in the calculator. Log base 9 of 81. Let's do it this way. 81 is 2. I wonder if I'll put both of them in there. I have not tried this before, so log base 9 of, oh, see there, it's not giving me the base. Maybe it does not like that. Yeah, maybe we can't do them both. So we have 2. So this part is 2 plus, let's maybe just do it this way. Base 9 of 9 is 1. So we hope that when we put 729 in there, we'll get, what, 3? 729 is 3. So it does work. So this is our first property. It says, as long as they have the same base, which we'll include that here, log of base b, so we use b as our base, of anything that's being multiplied together, that means you are allowed to actually separate them into two different logarithms, log base b of x plus log base b of y. So they keep the same base, and you can actually separate the two numbers. So we kind of practice both. We can go from multiplying them together and separating them, or we can have them separate and go back together into one. We're going to practice both of these things in the next two examples. So expand the following. Log base 10 of 8x. So we just keep log base 10. And then we're going to separate 8 times x. So it'll be log base 10 of 8 plus log base 10 of x. If you're confused as to why I put plus there, make sure you look at this property. If you have multiplication between two things inside of one logarithm, you can separate it and put a plus between them. Use the same base, and then you should separate them with 8 and x here. For b, if you have 3 times n, same thing. keep the same base of 2, and the 1 will be 3, plus log base 2 of n. And the last one, you have 25 and 125, log base 5 of 25, plus log base 5 of 125. Keep the same base and just separate what's being multiplied together. All right, now we're going to try some more condensing ones, put them back together. So we have log base 10 of 10. As long as they're the same base, we can put them together. So this would be 1 log. Remember, you don't have to write 10 here because 10 is the common logarithm. I didn't have to do it up here either. You don't have to write log base 10. Log is just known to be base 10. So I can put these together as x times 13, or 13x if you want. Either one's fine. Log 13x. Part B, check to see if they have the same base. They do. So this is log base x. And then 4 and 3 go together. But how do we put them together? You multiply them. 4 times 3 is 12. The last one, log base 4 of 5 plus log base 7 of 3. 4 and 3, or 4 and 7, are not the same base. Not possible. You're not able to condense them. Have to have the same base. Okay, next property. Simplify the following here. What's log of 100 minus log of 1,000? Oh, shoot. Log of 100 is... Now here they're not using base 10, but remember we have to actually put in base 10. So I'll just delete it and put the log base 10 here. 100 is 2. So we have 2 minus 1,000. Just put another 0 in there. 3 equals -1. Now, what if I put this in as one thing, log of 100 over 1,000? Let's see if I can do that. Log of 100 divided by 1,000. Look what we get, -1. So can you see this new property? The last one we used addition between the two logarithms. There was addition here. But when we put them together, we actually multiplied these two numbers together. You see the difference here? When we have subtraction now, that leads us to putting them together and making a division. Whatever the one that has subtraction in front of the log here, that's the one that goes in the denominator. So the 1,000 is on the bottom. The other one is the numerator. So it goes numerator on top, the bottom is denominator for the second number. So it actually works the same way. It's kind of a similar property. So you have addition and multiplication going together, and now we have subtraction and division going together. So our next property, as long as they have the same bases, log base b x over y. So if you have division, we can separate that into two different logarithms, keeping the same base. Log base b of x minus log base b of y. So we're going to practice expanding them and condensing them. So we're going to go both directions. We'll go from here to here and then back the other way. So expand the following. So if we have division here, the one that's on the bottom gets the minus sign. Otherwise, we keep the same logarithm, the same base. So we have log base 4 of x comes first, minus log base 4 of 8. That's all there is to it. Part B, log, we have to keep the same base, x, y comes first, it's on top, minus log base x of z. And the last one, log base 2 of 6 minus log base 2 of y. All we really have to remember is when you have division with one logarithm, it splits into two logarithms with the same base, and the denominator is the one that has the minus sign on it. All right, let's put these together. Log base 2 of x minus log base 2 of 17. That means this part is the denominator. We're going to write one logarithm, log base 2. Got to keep the same base. X is on top over 17. That's all you have to do. Part B. Look at the same base, 5 and 2. They do not have the same base. You cannot condense them together, so it's not possible. And the last one, 3 and 3. You can put them together. Log base 3, this is the top number, 15 divided by 5. So this will be the only one that we actually go a little further with. The last one over here, we had an x. We can't simplify that. But you are allowed to actually divide these numbers if you can simplify it. So we'll make this log base 3 of what? 5 goes into 15 3 times. So log base 3 of 3. The very last thing that we have to cover now. Converting logarithms that are not in base 10 to base 10. So if you have something like any of these ones up here, like part C, log base 3 of 15 or log base 3 of 5, if you have something that's not a base 10, this is base 3, you can change it to base 10. Now, why would you want to do that? One of the biggest reasons is you can do it on your phone calculator. So whenever you pull up your phone calculator, which is probably similar looking to this, you only see a log button, and that's base 10. So you have to know how to use something that's not in base 10 if you have a calculator that does not include a base 10. So I'll show you how to do it with this calculator here, as if it's your phone calculator. So you don't necessarily need the website every time, as long as you know this property, because your phone can't do the little tiny base. Okay, so we're going to start with log base b of x. So this can be any numbers, b and x. The way you convert it is you make it into two logarithms. You do log base 10 of x divided by log base 10 of b. So this is called converting to base 10. You basically change into a division problem. You make both of them base 10. The top number is your big number here, and the bottom number is your base, your original base. Another way to write this, which I think I like a little better, is that we don't have to keep the base 10s. So in your calculator, you're just going to have to hit the log button. So you just do log of this number here, so log of x, and you divide that by log of b. So that's how you deal with something that has a different base other than 10. And that will give you the exact same answer. So I'm going to show that to you. I can probably do it in both calculators. So log base 2 of 30, we're going to evaluate this by converting to base 10 first. So I'm going to use the property up here. Log base 2 of 30, all you have to do is write log on top. The x came from the big number out here, so it's log of 30 divided by log, so I'm just using this property right here, log of b, in our case, is 2. So let's put this one in first. So if you have your phone calculator, you might have to do it a little differently. I think you have to put the number in here first, actually. So like I basically have to do like 30 and then hit log, I think. Yeah. So log of 30 is up there. It's hard to probably see, but that's log of 30. And I'm going to divide that by, let's hope this works, 2 log. I think that works. 0.3010. I'm not familiar with using this specific calculator, but hopefully that gives us the same thing. So 0.3010. I'm going to check that in the GeoGebra site. So we're going to change this to 2 in here. 2. And then we'll change this to 30. And the bottom is also 2. Oh, wait, we want this to be 10. That's right. It's log base 10. Oh, I have to do the whole thing over again. It's 2 logs. I hope I can actually do it in this one. Oh, no. I'm doing the original one. Duh. Sorry, I messed up. I was trying to put this one in, but we're actually doing the first one. This one here, yeah. Log base 2 of 30. So that did not give me the same thing as that. I wonder why. It even says this was right. So I wonder why. Log. Oh, yeah, you have to press the button first. 30 log divided by, maybe I'll do this. About 2 log. Interesting. Hopefully this does work on your phone. I'm just gonna try it on my phone. So it's log 30. Yeah, it works on my phone. I don't know why it's not working on here. Unless for some reason, because it seems like it's dividing by 2 first. So if I did 30 log, so it's 1.477. Maybe do it this way, 1.477. And remember what that number is. And then if I did 2 log, oh yeah, it's only calculating the log of 2. It's not doing both of them. So this calculator does not do both things. So I'd have to manually put in 1.477. I'm not going to get a perfect answer. Divided by the 0.3010. There we go. It's a little bit better. The 4.9 and 4.906. Okay. So that was way different than what I'm used to with my calculator. So I would suggest maybe not using this one. This one's kind of messed up. So this should actually be 4.906. In both ways that you do it. So I did it the correct way now. I just found out what log of 2 was first, and then did log of 30 and had to divide the 2. Because for some reason, this calculator was only doing log of 2. But now I know that. It can't possibly do both of them, I guess. So for part B, log base 4 of 5, we're writing this as base 10. We can write this as log what goes first. Look up here again. The x is what goes first, so that'd be 5. And the bottom is log of 4. I had no issues putting it in my phone calculator. If I turn it sideways, it comes up like that. I was able to type in log of, the last problem was log of 30 divided by log of 2. And it got me the 4.906. So hopefully it works for you if you use your phone calculator. So what should this be? I don't like using this one. This one takes way too long, but I'll try it again. So log of 5, which is weird because you have to hit 5 first and then hit log. So 0.6989. And then we're going to do log of 4. 0.602. Does it save them? 0.602. Okay, so 0.6989 divided by 0.602. 1.16. Let's hope that's even close to the thing you get in GeoGebra. So I'm changing this to 4, and this to 5. 1.16. Okay, we got the same thing. So it does work. And the last one here, log base 8 of 4, we'll change this to log of 4 over log of 8. And I'm just going to put this in GeoGebra 1 because this specific calculator is kind of frustrating to use. If you ever need to use it, I would advise just use like your phone calculator. It does a lot better of a job with it. So I'm going to try to put it in GeoGebra now the right way. Let's see if I can do it. Log 4 over log 8. Log 4 divided by log 8 is 0.6 repeating. 0.6 repeating. Let me see if that's the same answer if I have log base 8 of 4. Log base 8 of 4. There it is, 0.6 repeating. Actually, I should just use this calculator to begin with when I was dividing it. The other one's a mess. I would highly advise not using that one. So that's the last thing. So if you need to actually just use your phone calculator, you can. You don't have to do these ones with different bases on this website or on a graphing calculator. You don't need either one. You can just use your phone, which works way better than your laptop calculator. I would not advise using that one. So that is the end of the video and of the lessons that we're going to be doing. Hope you have a great summer, and we'll see you next year.